Now, next one. How many pair of positive integers are there such that the LCM is 2012? 2012. Now see, 2012 is nothing but 2 into 1006. These are nothing but 2 into 503. These are nothing but 2 square into 503. 2 square into 503. LCM of A comma B. I will tell you traditional method, then I will tell you an optimal method. LCM of A comma B is 2012. One is the traditional method. One is the traditional method. In the traditional method, A we don't know, B we don't know, but the LCM of A comma B is 2013, which is 2 square into 503. 2 square into 503. What is the definition of LCM? LCM always takes highest power of the given prime basis. LCM always takes highest power of the given prime basis. Answer is 2 square into 5 power 3. Question also it should have right 2 power. 503. Question also it should have 503 power. 503 y1 y2. LCM always takes the highest power of the given prime basis. Maximum of x1 and x2 it is 2. That means if x1 it is 2, x2 can be 0, 1, 2. Am I right? 2 square, highest is 2 square. 2 square, 2 power 0. Highest is 2 square. Similarly, if x2 is 2, x1 can be 0, 1, 2. But 2 comma 2 it is double written. So it is 5 cases. What are the 5 cases? 2 comma 0, 2 comma 1, 2 comma 2, 0 comma 2 and 1 comma 2. I hope it is clear. Similarly, maximum of y1 and y2 it is 1. So if y1 is 1, y2 is 0 and 1. If y2 is 1, y1 is 0 and 1. So these nothing but 1 comma 1 it is eliminated. 5 into 4. 5 into 4. 1 0 1 1 and 1 0 1 1 and 0 1. 3 cases. 5 into 3 is total 15 cases. This is the traditional method from the definition of LCM. LC always takes the highest power of the given prime basis. LCM always takes the highest power of the given prime basis. First I factorized 2012 as 2 square into 503. A and B. 2 square is there in the answer. Maximum of x1 and x2. It should be 2. y1 and y2 it should be 1. y1 and y2 it should be 1. 5 into 3, 15. But you can also do it in a quicker method. That also we will discuss. Please observe, in all these doublets, x1 is 2 or x2 is 2. In these doublet, x1 is 2 or x2 is 2. Right? In these doublet, 1 is present in every doublet. Now, please write down, sir. Please write down. These are nothing but LCM of A comma B, which is nothing but 2012, which is nothing but 2 square into 503. 2 square into 503. That means, that says that at least one of A comma B should contain, at least one of A comma B should contain 2 square into 503 power 1. At least one of A comma B should contain 2 square into 503 power 1. At least one is nothing but total minus none. At least one is nothing but total minus none. Total how many powers of 2 can be distributed onto A? 2 power 0, 2 power 1, 2 power 2. B also 2 power 0, 2 power 1, 2 power 2. None. None means don't take 2 power 2. 2 power 0, 2 power 1. 2 power 0, 2 power 1. So, these are nothing but 3 square minus 2 square. Right? Total minus not taking the highest power. Again 5 also. 503 power 0. 503 power 1 for A. 503 power 0. 503 power 1. Total minus not taking 5 power 1. This is nothing but 2 square minus 1 square. 2 square minus 1 square. 9 minus 4, 5. 4 minus 1, 3. 5 into 3 is nothing but 15. At least 1 is nothing but total minus none. At least 1 is nothing but total minus none. Total all the powers of 2 onto A and B. Similarly, don't take 2 square. Don't take. At least 1 should contain 2 square means all the powers of 2 minus do not take powers of 2. Total minus 1. At least 1 student sitting in my class should get an 100 percentile in maths. Total. How many students attended the class minus none of the students who got the 100 percentile. I hope it is clear, right? Is it clear, right? 2 power 0, total minus 9. These are an extremely important logic. If you know these logic, some complex questions, you can solve it very, very easily. We can further simplify. Now, I will further simplify. See here, sir. LCM of A comma B is 2 square into 503. What is that I am using concept? Total minus none. Listen carefully, sir. If you know this, next 5 problems are very, very easy to you. Total. First we will start with the first prime base. Total 2 square. 2 power 0, 2 power 1, 2 power 2. A can take 3 cases. B can take 3 cases. Total cases are 9. Distributing all the powers of 2. Minus, none. Don't take 2 square. A can take 2 cases. B can take 2 cases. 9 minus 4 is 5. I hope it is clear. Into total 503 power 1. A can take 2 cases. B can take 2 cases. A can take 1 case. B can take 1 case. 5 into 3. It is nothing but 15. It is nothing but 15. Now, we will solve 5 problems. First problem. LCM of A comma B is nothing but 72. 72 is 2 cube into 3 square. 2 cube into 3 square. Total 2 power 3. 2 power 0 to 2 power 3. A can take 4 cases. B can also take 4 cases. Minus. Don't take 2 power 3. 0 to 2. 3 cases. B also can take 0 to 3. 3 power 2. A can take 0 to 2. 3 cases. B can take 0 to 2. 3 cases. Similarly, write 0 to 1, 0 to 1. I hope single step how you are getting. 16 minus 9 is 7. 9 minus 4 is 5. 35 values. Pairs it will take. Second question. Second one. LCM of ABC. It is nothing but 100. 100 is nothing but 2 square into 5 square. 2 square into 5 square. What is the concept that we are using? We are using total minus none. We are using total minus none. A will take from 0 to 2, 3 cases. B will also take 3, C will also take 3. A will take 2 square, 2 cases. B 2 cases, C 2 cases. I hope it is clear. Into 5 square, 0 to 2, 3 cases. 3 into 3 into 3. Since the power is same, it will be the same. 2 into 2 into 2. So, these 27 minus 8, 19. 19 square is 361. 19 square is 361. LCM of A, B, C, D. It is nothing but 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. A will take 0 to 3, 4. 4 variables are there. Don't take 2 power 3. Similarly, 3 square, 0 to 2, 3. Right, don't take 3 square. 0 to 1, 2. 2 power 4 minus 1 power 4. I hope the idea it is crystal clear. A 2 minutes problem became an 30 seconds problem with this negation approach, which is total minus none. Which is total minus none. Now you can develop as many questions as possible and you can solve it. Next one. Find the sum of all the digits in the decimal representation of all the positive integers less than 1000. Positive integers means We will start with 1. 1, 2, 3, 4, 5, 6 and so on up to 996, 997, 998, 999,000. Sum of all the digits. Sum of all the digits. First, let us see how many times the digit will appear in all the natural numbers from 1 to 1000. First, we will see how many times the digit 3 will appear. How many times the digit 3 will appear? Let us see. Or first, a digit n will appear. N could be anything. We will take some examples. How many times the digit n will appear? If n it is 3. Units place, tens place, hundreds place. If units place, if it is 3. This can be from 0 to 9. This can be from 0 to 9. If the leftmost is 0, I will get all the possible 2-digit numbers. If both are 0 zeros, I will get all the single digit numbers. So 10 into 10, 100. 10 into 10, 100. Similarly, tens place it can have 3. Hundreds place it can have 3. Here also it is 0 to 9. Here also 0 to 9. Here also 0 to 9. Here also 0 to 9. So 100, 100, 100. 100 plus 100 plus 100. It is 300. A doubt might get in for a student. Sir, you are doing 333 3 times. 333 is counted thrice because digit 3 is present thrice. I hope it is clear. It is not how many numbers contain digit 3. How many times the digit 3 is present. In 33, 3 is present twice. So 33 is counted twice. 333, the digit is counted thrice. So 333 is counted thrice. Any single non-zero digit will appear from 1 to, I hope it is clear. Any single non-zero digit will appear from 1 to 999. How many times? 300 times the digit will appear. 300 times which all digits will appear? 1 can appear, 2 can appear, 3 can appear, 9 can appear. If I take 0, 0 into 300, 0. So answer is nothing but sum of all the digits. 300 into 45. Easy question. If you know the logic, you can solve it. From all the natural numbers from 1 to 999, every single digit appears 300 times. Any digit appears 300 times. Appears 300 times. A digit appears 300 times from 1 to 999. From 1 to 999. Digit could be from 1 to 9. If you know this concept, this question is easy to you. I hope the idea it is clear. Next one. Let A, B, C, D are 4 real numbers. Okay. A plus B plus C plus D is 8. AB plus AC. Combination of 2 it is given. So, I will do A plus B plus C plus D. Whole square it is nothing but A square plus B square plus C square plus D square plus 2 into the entire combinations of 2. 4 variables are there. 4C2 6 combinations I should get. AB, AC, AD, BC, BD and CD. These are nothing but A square plus B square plus C square plus D square. It is 64 minus 24, 40. That means I will not use these equation. I will use these equation right now. A square plus B square plus C square plus D square. It is nothing but 40. It is nothing but 40. Now see here. A plus B plus C plus D. It is 8. Next is A square plus B square plus C square plus D square. It is nothing but 40. What is he asking? Greatest possible value of A. D, greatest possible value. So D is nothing but 8 minus of A plus B plus C. So D is maximum. That means ABC should be minimum. It is given real numbers, so we don't know. If it is given natural number, I would have substituted 1. So ABC minimum value, let me call it as X. let me call it as x. X plus x plus x plus d, it is nothing but 8. 3x is nothing but 8 minus d. 3x plus d, it is nothing but 8. So d is nothing but, d is nothing but 8 minus 3x. D is nothing but 8 minus 3x. So this equation is d square equivalent to 40 minus of x square plus x square plus x square. D is nothing but 8 minus 3x whole square equivalent to 40 minus 3x square. 40 minus 3x square. I hope it is clear, right? So from there you will get the value of x, substitute here, you will get the value of maximum d. I hope the idea it is clear. Or what you can do is 3x plus d, it is nothing but 8. D is nothing but, x is nothing but 8 minus d by 3. You can substitute in the equation, that also will give you directly the value of d. You do it in any way. This equation replace it with a square plus b square plus c square plus d square is 40. Next one, recursive and iterative function, most right commonly asked questions. F of n is nothing but 4n plus root of 4n square minus 1 divided by root of 2n plus 1 plus root of 2n minus 1. So you can write these 4n as root of 2n plus 1 whole square plus root of 2n minus 1 whole square. A square plus b square, this is nothing but root of 2n plus 1 into root of 2n minus 1 divided by 2n plus 1 plus root of 2n minus 1. If I multiply it with root of 2n plus 1 minus of root of 2n minus 1, this root of 2n plus 1 minus of root of 2n minus 1. A minus b into a square plus b square plus ab, this is nothing but a cube minus b cube. A cube minus b cube. Denominator a square minus b square. This is nothing but 2. So this is nothing but root of 2n plus 1 whole cube minus of root of 2n minus 1 whole cube divided by 2. This is actually f of n value. It is actually f of n value. Now it is simple substitution, you will get the answer. Right? I hope the idea it is clear, right? This is root of 2n plus 1. Now if you see here, this is nothing but f of n is nothing but root of 2n plus 1 whole cube minus of root of 2n minus 1 whole cube divided by 2. F of 1 is nothing but, f of 1 is root 3 whole cube minus root 1 whole cube divided by 2. F of 2 is nothing but root of 5 whole cube minus root 3 whole cube divided by 2, and so on up to f of 40 is nothing but root of 81 cube minus of root of 71 cube divided by 2. All intermediate values will be cancelled. Calculate it and you will find the answer. I hope the idea it is clear. Simple final step, add and you will get the answer. Right? Very, very good question it is, sir. Right? Next 3 questions are very, very good questions. X equivalent to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 till plus or minus 10. How many distinct values, how many possible values x will take? If I want x maximum value, x is plus 1, plus 2, plus 3 and so on up to plus 10. This is nothing but summation 10. N into n plus 1 by 2, which is nothing but 55. Maximum value x can take is plus 55. If it is minimum, x is minus 1, minus 2, minus 3 till minus 10. This is nothing but minus summation 10. which is minus 55. Now the question is whether all the values we will get or any other values will be omitted. So x value oscillates between minus 55 and 55. X value oscillates between minus 55 and 55. Concept. Suppose if it is plus 1, plus 2, plus 3, the sum is nothing but 6. Sum is nothing but 6. Let me replace plus 2 with minus 2. Plus 2 with minus 2. 4 minus 2, the sum is nothing but 2. If you observe closely, these nothing but the same sum where all are positive minus 2 became minus 2. So the drop is 2 into the number whose sign is changed. Am I right? Number whose sign is changed. Obviously 2 became minus 2 means the drop is minus 4 only, right? Or if these nothing but total sum, these nothing but total sum minus 2 into sum of all the numbers whose signs are changed. Sum of all the numbers whose signs are changed. Total sum minus 2 into sum of all the numbers whose signs are changed. So the total sum is nothing but 55 minus 2 into some value p. 2 into any number even. 55, it is an odd number. Odd minus even is odd. That means what are the values x will take? X will take all in odd integral values. X will take all odd integral values from minus 55 to 55. X will take all the odd integral values from minus 55 to 55. Very, very good question it is, sir. If x maximum we want means all are plus. So summation 10 is 55. X is minimum means all are minus, which is minus 55. Minus 55 to 55, the value oscillates. If the sign is changed, if 2 is becoming minus 2, the net effect will be double the value whose sign is changed. If 3 is becoming minus 3, the drop is minus 6 only, right? If 4 is becoming minus 4, the drop is minus 8 only, right? So 2 is becoming minus 2, the drop is 2 into the number whose signs are changed. If more than one number signs are changed, add all the numbers and put it as 2 into. This value I am calling it as P. 55 is an odd number. 2 into any number, even number. Odd minus even is odd. Answer is all the odd integral values from minus 55 to 55. Minus 55 to minus 1, 55. 0 to 55, 56. Total 111 values, odd integral will be 56. Answer for this question is nothing but 56. Answer question is nothing but 56. I hope the idea it is clear. If a number sign is changed and it is getting added, the net change will be 2 into that number with a minus sign before. That is the learning from this question. Next one, it is ending with 11. So it is x is plus 1 plus 2 till plus 11. X maximum, which is summation 11, which is 66. X minimum minus summation 11, which is minus 66. Minus 66 to 66. So what will be the total possible values? Total possible value is total sum possible, total sum, right? Best case, minus 2 into the numbers, sum of all the numbers whose sign is changed. Sum of all the numbers whose sign is changed. Total sum is 11 into 12 by 2 minus 2 into any number even. These also even. Even minus even. Answer is even. So all even integral values. All even integral values. 67 will be the answer. Starting and ending both are even. I hope the idea it is clear. I hope the idea it is clear. So if the signs are changed, the net effect will be 2 into the number whose signs are changed. I hope the idea is very, very clear to you. 11 into 12 by 2 minus 2 into any number even. Let me create one more question so that it will be very clear to you. Question is, by changing the sign of how many numbers? By changing the sign of how many numbers? By changing the sign of how many natural numbers will the sum of 2005 natural numbers, will the sum of 2005 natural numbers becomes 2006? Beautiful question, sir. By changing the sign of how many natural numbers will the sum of 2005 natural numbers becomes 2006? 1, 2, 3 till 2005. Sum is nothing but 2005 into 2006 by 2. These 1003. Odd into odd is odd. So answer is nothing but odd number minus, if the sign is changed, 2 into sum of all the numbers. Sum of all the numbers whose signs are changed. Sum of all the numbers whose signs are changed. This is odd. 2 into any number is even. Odd minus even is odd. I will only get the answer odd, but this answer is asking even. So answer is not possible. In any case, you will not get the sum as 2006. In any case, you will not get the sum as 2006. I hope the idea is crystal clear to you.